Hello everyone, welcome to the Captain DevOps YouTube channel again. Today we'll be taking a look at this fine module of the AI-102 certification, which is fine-tune a language model with Azure AI Foundry. And today we'll be just taking a look at how we can get base language models and fine-tune them to achieve more specific tasks. This is a subject that I'm not too familiar with, and it touches a bit on the lower level side of AI models. So we will probably be learning this together. But let's get started. So as an introduction, language models are pre-trained models that provide you with a great starting point, and by using one of the available base or foundation models, you can save time and effort as you need less data to train a model for your specific use case. So here is a bunch of, yep. If you're a developer working for a travel agency, when customers use your chat application to get help with their travel-related questions, you want the responses to be in a specific format and style. And if your company has a specific tone, then the marketing department finds it important that the chat application is aligned with the company's tone of voice too. And there are various strategies to optimize the model's behavior and the performance of your chat application. One of them is to fine-tune the language model, which can then be integrated into the chat application, just as the base OpenAI models, such as GPT-4, for example, are available as APIs. I suppose the fine-tuned models are also available through this method. The benefit of fine-tuning over training your own language model is that you need less time, compute resources, and data to customize the model to your needs. So pretty much what fine-tuning here is being introduced here is as sort of an alternative to training your own base model from scratch. And you can keep in mind that if you want the model to behave differently, then pretty much you have to fine-tune it, or maybe work very hard on the system prompt of the language model. And I suppose we will get to sort of I suppose there will be sort of a diagram explaining this, but if there isn't, you should never start by fine-tuning a model, because it's a very specific and scientific sort of task that usually takes a while and consumes a lot of resources in the sense of not only on cost but also time and complexity, especially for testing if the fine-tuned model actually performs better than the vanilla one, let's say. So let's understand when to fine-tune a language model next. Before you start fine-tuning a model, you need to have a clear understanding of what fine-tuning is and when you should use it. So this is probably the diagram that I was thinking about earlier. When you want to develop a chat application with Azure AI Foundry, you can use PromptFlow to create a chat application that is integrated with a language model to generate responses. To improve the quality of the responses the model generates, you can try various strategies. So here it talks about prompt engineering, which is working on the system prompt. It's actually, you can also update the system message, which is the system prompt. In this case, prompt engineering is asking the user to provide a better answer. What else? Yeah, so prompt engineering is a quick and easy way to improve how the model acts and what the model needs to know. And when you want to improve the quality even further, there are two common techniques, which is retrieval augmented generation, which we saw in the last video, and the fine-tuning, which is sort of adding more training to an existing model. So here we have two axes, which is the context optimization, which is what the model needs to know, and the model optimization, which is how the model needs to act. Here, we see that RAG is the most commonly applied when we need the response to be grounded in specific data. On the other hand, when you want the model to behave a certain way, fine-tuning can help you achieve your goal. You can also combine both strategies like in this corner of the image here. And when we think about how we want the model to change how it acts, we are talking about here the style, the format, the tone of the responses, and we can do this using prompt engineering, but it might not be the most consistent way to get the model to act how we want. For example, if you want it to only, I don't know, answer in Portuguese, for example, maybe with only prompt engineering, sometimes the model can ignore the instruction and behave differently, which is kind of funny that they put that here. Within prompt engineering, the technique used to force the model is to provide various examples of what the desired output might look like, also known as one-shot and or few-shot examples, which we also saw, I think. And it still can happen that the model doesn't always generate the output that we want. So to guarantee this, we can fine-tune a base model with our own training data. And this goes a lot into how AI models are trained. And this goes back to how much machine learning models in general are trained, not really just generative AI models. So this is a very this is an older field, I believe. So prepare the data to fine-tune a chat completion model. This involves combining a suitable foundational model to use as a base, which I believe is this cube here, and a set of training data that includes example prompts and responses that a model can learn from, which is the document here in the language and in the image. And we combine both of them to get the base model plus a little bit of a differentiation for our specific use case here. When we want to fine-tune the language model, we need to identify the data set we can use to fine-tune it. And similar to any machine learning model, the quality of the data set has a large effect on the quality of your model after being fine-tuned here. Though you need less data than when you would train a large language model from scratch, you would still might need enough data to maximize the consistency of your desired model's behavior. How much data you need depends on your use case. And this goes back to what I talked about in the sense of fine-tuning a model is very similar to the engineering part of training machine learning models in general, in which you need to provide some sort of example data for the model to be trained on. And based on that specific data, the model will be optimized to generate the same sort of responses that you provided. So as we saw earlier, I think, on this text, when we provide the data, we need to provide both the example prompt and the example response so that the model learns for a specific type of prompt what is the expected answer. And when we fine-tune a language model for chat completion, we use a collection of sample conversations, and more specifically, the data should contain three components, which is exactly what I was talking about by coincidence. So it's the system message, the user message, and the assistant's response. And apparently it comes in a JSON file here, which is not formatted, but it has a couple of messages, which is the system message, then the user message, and then the assistant message, which in this case is the response that we want the language model to provide. And it should have the ideal behavior. We can create this data set based on the chat history of a chat application we have. And just keep in mind to remove any personal or sensitive information, and not only focus on creating a large training data set, but also ensuring that it includes a diverse set of examples. What else? Multiple turns of a conversation on a single line in the data set. And if we want to fine-tune only on specific assistant messages, you can optionally use the weight key value pair. When it's set to 0, the message is ignored, and when it's set to 1, the message is included for training. So here it's an example of a weighted file format. So let's see. Messages. So there's a system message, then there's the user message, and then the assistant message. So in this case, the assistant first provided a response that isn't the required or the expected answer, and then the user sort of pushed the model in the right direction here, and then the assistant said that Paris, as if everyone doesn't know that already. So it's more sarcastic, and then it has a weight of 1, which means that the model for its training data it's only going to consider this specific message here and not this one. When preparing the data set, we should understand the desired model behaviors, create the data set in this format, and JSON-L, which is, I believe, is a bunch of JSON objects here surrounded by curly braces, but not separated by commas, I think. And ensure the examples we provide are high quality and diverse. And by preparing the dataset, we have a higher chance that the fine-tuned model improves the chat application's performance. So one thing I'm not sure about here is how we can continuously validate if the fine-tuned model is actually performing better or worse than the base model for our use case. I suppose, I hope we discuss this in this module here, but if not, then maybe we'll spend a bit of time researching this a bit more. So when we want to fine-tune a language model, we can use a base model, and we can pick from the models available in AI Foundry, and we can fine-tune based on various tasks, like task classification, translation, or chat completion. Here we need to use a base model that can be fine-tuned on a chat completion task when we want to generate responses in a chat application. And here it says that we can filter on the type of test that we want our model to perform. And we can use the user interface provided in the portal. So here there are no screenshots here, but we'll just go through here the rest of the module for now. When we navigate to the catalog, we can explore all available language models. And though all available language models will appear in the AI Foundry model catalog, we might not be able to fine-tune the model we want depending on the available quota. So this is also something to keep in mind. So you can filter them. Having between foundation models, we can examine the description of a model and the reference model card. Here are some considerations before fine-tuning. So the capabilities, for example, a model like BERT is better at understanding short texts. The pre-training data, for example, GPT-2 is trained on unfiltered content from the internet that can result in biases. The limitations and biases on the foundation model, and the language support. So if we want to support a specific language, or we want the model to be multilingual, for example. There are a bunch of descriptions in the model catalog, but we can find more information in the model card, and the model cards come from Hugging Face here. So Hugging Face is a sort of I think about it as a GitHub of language models, and here are a bunch of them. But yeah, it's I believe the AI Foundry has a big integration with Hugging Face itself, which is pretty cool. So configuring the fine-tuning job, we need to fine-tune following the steps. So we select the base model, we select the training data, we select some validation data, which goes back to what I was talking about earlier, and also the advanced options. When we submit a model for fine-tuning, the model is further trained on the data, and to configure the fine-tuning or training job, we can specify the following advanced options. So the batch size, which is the number of training examples used to train a single forward and backward pass. In general, larger batch sizes tend to work better for larger datasets, and the default value and maximum value for this property are specific to a base model. A larger batch size means that model parameters are updated less frequently, but with lower variance. So what this means is that the batch size refers to the number of training examples used to train a single forward and backward pass. So this relates to how the training process actually happens. I'm not too familiar with how transformers work in this context because language models are pretty much all based on the transformer architecture from the Google paper that I think we discussed a while back. But a single forward and backward pass, I suppose it's a cycle of many that happen during the fine-tuning. And in the cycle, the model sort of tries to adjust its own weights to help generate similar responses to the examples, and I suppose that's the forward phase, and the backward phase is it validating that it got things right on some new data, maybe, not sure. The learning rate multiplier. So the fine-tuned learning rate is the original learning rate used for pre-training multiplied by this value. Larger learning rates tend to perform better with larger batch sizes, and we recommend experimenting with values in the range 0.02 to 0.2 to see what produces the best results. And a smaller learning rate can be useful to avoid overfitting, which I don't think we discussed this before, but overfitting is when you train a model so specifically that it can only relate to that specific scenario and not generalize its knowledge to other scenarios even if they're similar. So this is what overfitting is in a nutshell here. The number of epochs is the number of cycles, the full cycle through the training dataset. What else? The seed is the reproducibility of the job. Passing in the same seed and job parameters should produce the same results, but different in rare cases. And if a seed isn't specified, one is generated for you. So maybe you want to replicate a past fine-tuning that you perform on a model to get similar results, and the seed is used for that. Sort of like random world generation in video games, for example. After you submit the fine-tuning job, it will be created to train the model, and we can review the status of the job while it's running. What else? If you added a validation dataset, we can review the model's performance by exploring how it performed on the validation dataset, and we can always deploy the fine-tuned model and test it to assess its performance. And once we are satisfied, we can integrate it with our chat application. So here is the practical exercise, and it's going to launch the lab here on Microsoft Learn. And let's just take a brief look into it. So here's the front page of the AI Foundry, and then we can select a model, go into advanced options and customize here. Then we can create it on the model. After it's created, we can test the model. We can see the overview. And to fine-tune the model, first we need the training dataset here. In this case, it's for a hotel business. And then we can go into the fine-tuning section here in this image. Let me see if I can zoom in. Here on the fine-tuning. What else? A new fine-tuned model. We select the supervised customization, the base model that we just deployed, the training data that we just downloaded, the model suffix, and the seed here. And after it's fine-tuned, it can take a significant amount of time, 30 minutes or longer. And then we can chat with it to sort of test what we provided and how the fine-tune worked. Then we can deploy it and test it, and then the cleanup for the lab. All right, I think that settles our knowledge section. So let's just answer some questions here. So how must data be formatted for fine-tuning? And here we saw that it's JSON-L. I believe the L stands for lines. So So a bunch of lines of JSON objects that we saw, and they are not separated by commas. They are separated by new lines in the file. What does fine-tuning optimize in your model? How the model needs to act, which is very important. Which advanced option refers to one full cycle through the training dataset, and this is the number of epochs, because an epoch is the full cycle through the training dataset. So let's submit the answers, and that's correct. And let's go to the here. Awesome, and then let's complete this module here. And I believe the next module we have is the second to last one in this learning path, which is implement a responsible generative AI solution in Azure AI Foundry. So I'll be seeing you guys in the next video, and thank you so much for watching, and bye-bye.